So today we're going to start looking at our first section that's in our book, okay, and that's solving equations by adding or subtracting. On the agenda on the board, when I put it over on the side, when you see like in parentheses a 1 after it, what that means is we're going to spend a couple days on that. So like we're going to do part of the first section today, and then part of the first section tomorrow. Okay. So today there's only 2 things that you need to know how to do to both sides of an equation. That's add a number to both sides and subtract a number from both sides. That's it. All right, Mr. Roy, do you have an extra copy of guided notes?
I do, Mr.
Just so I can look at it?
Sure. This, guys, when we talk about these properties of equality, you're not going to need to write this stuff down. Really, the only thing you're going to do is just write the steps down on how to solve. So this stuff we talk about, the addition property of equality, the subtraction property of equality, just listen to that. You don't need to write it down, all right? I'll let you know when you have to write stuff down.
All right, so when we're dealing with equations, and we did this earlier in the warm-up, when you add a number to an equation, where do you have to add it? Like in 1 spot, 2 spots, 3 spots? Like where do you have to add it? Ellie?
You have to add it to the right.
Okay. Is that it?
Well, if there's more numbers, then you have to do it to that number. But like, if you have like an equation, you have to do like, it's like 16 and then x plus something.
Mm-hmm.
And you still have to subtract like 16 from the bigger number if there's a bigger number.
Okay. Anyone have anything to add to that? Yeah?
You have to do it to both sides.
That's it. You have to do it on both sides. So that's what this property says. Okay? And again, we're just reading this over. The addition property of equality says that you are allowed to add the same number to both sides, and it won't mess up the problem as long as you do it to both sides. All right? So let's just look at an example. Okay? So what's in that box, right? It says x equals 6.
Guys, this example, you don't need to write it down.
So what does it say x equals? What number? 6. Okay, I'm going to add 3 on both sides just to show you, okay, what happens. If I add 3 on the left, Alex, what do I get if I just add 3 to x? Can I add a letter and a number? No, because they're not like terms. So when I add 3 to x, what do I get? Yeah, just 3 plus x or x plus 3. And Yusef, what about when I add 3 to 6? What do I get?
1 plus 3.
Mm-hmm. So what do I get? 9. Yeah, exactly. So if you look at the equation that's in this box, which is like something you might see on a test, and then your goal is to get it to look like that, look at the answer. The one that's in the top box that says x equals 6. Look at the bottom box. What plus 3 gives you 9? 6. Exactly the same answer in each box. And Mr. Roy kind of showed you an example of this in the warm-up. Those are called equivalent equations. Since you did the same thing on both sides, whatever the answer to this one is exactly the same as that box. And that's the key. All right? By adding the same number to both sides, you don't mess anything up. As long as you do it correctly. All right. So when we're solving an equation, right at the top of your guided notes, that means, and you're going to fill in what's highlighted in yellow, find the solution.
So you're going to write in to find the solution. You have to solve an equation means, so on the blank, just going to write to find the solution.
Matt, did you sign back in?
Oh, I don't know. Wait, how do you sign back in?
Just scan ready.
Oh, you just scan here.
Yep.
Yeah,
So when we solve an equation, we're looking for a number. Okay, solve an equation, x equals 5. Y equals negative 12. Okay, we're looking for a number. Okay, this part, I don't think you have to write that down. As long as you understand when you solve an equation, that means get the letter alone. Get the variable alone. Does it matter if you get it alone on the left or on the right? Does it make a difference? No. I know there were a couple of you that said sometimes you switch the order, and Mr. Roy showed you that. How many people said they do that? They switch the order of the equation before they solve it? 4 or 5 people? Okay. Yeah, you don't have to. And if most of you don't, I'll just solve it the way most of you do it. Okay, but if you do want to switch it, that's up to you. So, we're not going to be checking every single problem.
This depends on the directions.
Yeah, if the directions say to check, just make sure you do check it, and that's going to be worth half the credit for the problem. We're not going to be checking every problem all year. Okay, it's just something that I want to know that you know how to check it. Once I know that, it's up to you if you want to check your own answers on a test. I would, just, make sure you get it right, but that's going to be up to you. Actually, so to check, before I show you, can somebody tell me, how do you check an answer? What do you think you do?
We had a fancy word for it last week.
Anyone have a guess at how you, yep, Donna?
You take the answer that you got and then plug it into like the letter, like X.
Yeah.
Plug it back into X.
Exactly. You plug it back in. So to check your solution, take what you got, plug it back in for the letter, and then see if you get a true statement. Okay, if you're not sure what we mean by a true statement, we're going to check a couple, and we'll see if we get a true statement.
Guys, when was when we gave you a number that like represented the letter, and we had to plug it in? Anybody remember the term we used for that?
Substitute.
Okay, you could call it substitute. We called it something else last week.
That's the first step. You substitute a number in for the letter, and then blank.
David?
Evaluate.
Evaluate. Good.
Yep.
So you want to do this part? You want me? You want to? Alright, so guys, you want to write this. This will be really outside of having to write the examples today. Alright? This will be the most writing we have to do. So on one side of your notes, on that top part, you have the steps, right? The bullets. On the right side, you have the example. So what we'll do, what we try to do is, as we go through each step, like the written directions, we will do the step in an actual example so you can see it happen. All right. So again, these are all one-step equations. So first thing we want to do. So here's your first step. And then here's your example. That's example 1. So the first thing we want to do is find, identify, whatever, see. We want to find the variable, all right, that's on one side of the equal sign. 85, 90% of the time, that variable is going to be on the left-hand side. Most of the time, it's going to be the first term in the problem. Right? It'll be the first thing. Sometimes, other times it could be like this. It could be, you don't have to write this down. It could be like that too. It could be kind of before the equal sign. It could be the second term. All right. Again, the ones we showed you in the warm-up, it could be on the right-hand side. All right, but most of the time, it'll be the first term in the problem. All right, so we're going to find the variable on one side of the equal sign. So, in this example, in example 1, right, what's your value? X. So all I'm going to do is take it and circle it. Is it a positive X or is it a negative X?
Positive.
Positive, how do you know?
Because there's no sign before it.
Yeah, don't get tricked, guys. This negative belongs to what number? Or what term?
12.
12, right? Because it's to the left of it. This belongs to the 12, or the negative 12. All right? Just because it's in between them doesn't mean this is negative. The side to the left If there's no sign, positive. That's the way it is. So we know our variable in this equation is x. Now, we want to move the number that's on the same side with the variable, all right? We'll move the number on the same side of the equal sign to the other side using the opposite operation. So we know we have a positive x, which we already identified, that's what we want to solve for. And then we have, again, you don't have to identify what the number is. If you do, that's great. But again, I showed you guys that this did not get tricked by putting the negative with the, or the sign that's in the middle with the first term, or the variable. So for this, we're going to move whatever's on that side, whatever number's on that side with the variable, that's what we want to move. We want to get it to the other side. All right? So we already know the number on the same side with the variable is negative 12. So math, to move that based on the directions, what am I going to do? So I want to use the opposite operation. So it's minus,
Just gonna add 12.
add 12. I added here just to show that it cancels out. What else am I adding it to, Matt?
The 9.
The 9. On this side, what happens? What can I do? Let's cross it out. Right, that's gone. What am I going to make sure that I do? Again, it's not super important, but you want to make sure you do this because you don't want to forget. Anybody know? The jelly? Bring the x down. Again, it seems like, it's common sense, but some people forget to do that. They're like, oh, I screwed up. Bring the x down. Ellie, what are we going to do?
Add 12 to 9, which is
12 and 9. The answer going to be positive or negative?
positive.
How do you know?
Because 12 is positive.
They're both positive, right? And the rule is what?
Positive plus a positive plus a positive.
Yeah. If it's the same sign, keep the sign, which is positive, and then add the numbers together. 9 and 12 is what?
21.
21. X equals 21. I might have skipped this step here, guys. I'm sorry. We just did that, right? Add or subtract. In this case, we had to add. All right. So we moved it, and then we added. Last step is going to be what? Ellen?
Solve.
We already did that.
Oh.
What was one thing? We're not going to do this all the time, but mainly like this week.
You want to plug in 21.
Plug in 20.
We're checking.
Oh, check. Yes. I said no.
So you plug in 21.
Yeah. So like Melanie, right?
Yes.
Yes. Like Melanie just said, check. So what we just solved for, evaluate, like we talked about, evaluate with the number we just solved for. So what I'm going to do is, guys, you don't have to do this, but I do it this way so you can see it. I'm just going to take this equation and write it out again. There it is. Now I want to do that last step. I want to check. So what should I write? I want to check it now. I know what my x is, so now I want to check it. Melanie?
Isn't it x minus 3?
Oh, x, I screwed up, sorry. There we go. So what do I want to do? What should I write? Savannah?
21 minus 12.
Yeah. 21 minus 12 equals 9. Melanie already told us 21 minus 12 is 9 equals 9. So, when we're talking about things being like equivalent, basically, when you check it, when you do the math, if it matches up on either side, 9 equals 9. Yes, that's true. 9 is 9. Right, it's just basic. Right? 9 is 9, the numbers match up. Yes, it checks. Alright? And those are our steps. Find the variable, whatever number's on that side with it, do the opposite of it on both sides, do the math on the right side, usually sometimes on the left, and then check it, depending on if we ask you to check it or not. We're not always going to do that. But especially as we get into more, later in the year, we're not going to ask you to check. So those are the steps, all right? And again, it might be this basic stuff, but again, it's a good refresher for you guys, all right? So now, same thing. We got solve, and it's asking us to check as well. All right? So this is kind of one of those funky ones. So on your notes, guys, you have example 2, then you just have some space. So you want to write the example. Now you have 2 options here on what you could do. What's one of those options? Use.
Can't you like put the Y like?
Yeah, you can do that. So when I rewrite it, what would it look like?
Y.
Say again.
Y equals 3 minus 4.
No, we're not gonna move around equal signs or anything. So when I rewrite it, what's it gonna look like? Dylan, right? Dylan, when I rewrite it, what's it gonna look like?
Y equals 3 minus 4.
Careful. Emily?
Y minus 4 is 3.
Exactly. See now, Dylan? Y minus 4 equals 3. All I'm doing is taking this information, putting it over here at the beginning, because we're used to having the variable on the left-hand side, and then taking the number and moving it to the end. Another way you could write it is like this. Does anybody think they know another way you could write it? A little bit trickier, but Ellie?
3 equals y in negative 4 in parentheses.
You could do that, but it's kind of the same thing. But like moving stuff around. The jelly?
1 minus y equals 3.
Say again?
1 minus y equals 3.
No. How about this? The negative, what does it belong to? The 4, right? And what's y? Positive or negative?
Positive.
Positive. That too. But again, like I'm saying, you have to know that the negative 4 is, that the 4 is negative and the y is positive. I think the best way to do it is like this, or if you want to go ahead and solve it, you can do that too. It's completely up to you. Alright? I know some people get a little nervous when they see it out of order. Alright? Like I said, you can do it like this, you're not wrong, and this takes a little more thinking to kind of get it set up. It's up to you how you want to do it. Alright? I'm going to do it this way. I like it consistent with the variable at the beginning. Alright? Catherine, what's my first step? If you're not sure, look at your notes. The first step in our notes that we wrote is what? So tell me. Y is a variable. Excellent. Alright. Nathan, next step is what? So first step, find the variable. That was y. Now we're on that second bullet. What was the second bullet?
Move the number to the other side.
So what's the number with y? Make sure you tell me the sign too.
4.
Is it positive or negative?
Negative.
So what do I have to do?
Add.
Add 4. Add 4 there to show it cancels out. Where else am I adding 4?
The 3.
To the 3. Nathan, negative 4, positive 4. What happens?
It cancels out.
Cancels out, right? That's the whole reason. Oh my god. Oh, what happened there? Alright, so we did that. So that cancels out like Nathan just told me. Make sure, bring your y down. And when I do, Miguel, when I do 3, positive 4,
7.
positive 7. Am I done? Am I done?
No.
How come?
You need to check it.
Check it, right? Chris, how do I check it?
You replaced a y with 7.
Alright, so tell me what to write. You want to do it this way, the way we did it here, you want to do the way it was written originally. It's up to you.
The second one.
The way we set it up, okay, tell me what to write.
7
Correct.
minus 4 equals 3.
Alright, then we just do the math,
Subtract 7 minus 4.
which is,
And 4 and it's 3.
and then what else do I write?
Equals 3.
It's good, right? What do we call that? What's the fancy word for that? Starts with an E, not evaluate, but equivalent, right? It matches up, it's equivalent. 3, sometimes equals means, when we do like word problems and stuff, means is. 3 is 3. It sounds weird, it sounds like common sense, but that's all we're asking you to show is that it's equivalent. Yes? Alright. So again, that's a funky one. You're probably gonna see a funky one like that on the test on Friday. It's up to you how you want to do it. You can rewrite it or just go ahead and solve. Either way, I don't care. We're not gonna take points off. Let's put it this way. We're not gonna take points off if you don't rewrite it. Alright? You don't have to. Like, you just go ahead and do it. Alright? So we talked about what was the first one we did? The property of addition, right? So now I want to do the property of subtraction. Alright? So the subtraction property of equality. Alright? So the one we did before, Mr. Hager showed you guys, if we added numbers on both sides, we would still get something that was equivalent. Alright? Here, if we subtract the same number from both sides, we're still going to get something that's equivalent. Alright? Again, you don't need to write this. So same thing. I get x equals 8. Down here, we subtracted 2 from both sides. We subtracted 2 from both sides. Alright? So x equals 8, x minus 2 equals 6. It's the same thing. If I evaluated or plugged in 8 for x, 8 minus 2 is 6. 6 equals 6. Again, it's just showing, but it's kind of showing you guys why this works and what the problem is. All right, we're not going to ask, on the test on Friday, we're not going to ask you to like, okay, we're not going to ask you to write the subtraction property of equality. You're not going to have to do that. As long as you know how to apply it, you're good. All right? So again, it's like the addition, property of equality. This is the subtraction. We're showing you guys how it works. Alright, so another solvent check. Guys, we'll give you 30 seconds. Do this one. You've heard us talk for quite a bit. You guys can do this one on your own. I don't think you'll need this one anyways, guys, for the reference sheet. If you do, I'll make sure that's all set.
Alright, so it says solve and check. How about Matt? You think you can tell me my first step?
You want to subtract 6 from both sides.
Okay, how come? What are you trying to do here?
Make x be on its own.
Exactly.
X is a variable.
Trying to get x, which is the variable, all by itself. So Matt told us I'm going to subtract 6 from both sides. On the left-hand side, Chris, what happens with plus 6 minus 6?
Cross it out.
Cross it out, it's gone. Anything still on the left-hand side though?
X.
Yep, x is still there. So we just bring it down. And Laurel, the only thing I have left to do is what's on the right-hand side. And what's 10 minus 6? 4. So we get x equals 4. All right. Nigeli, am I all done? Yeah, I have to check it. So Mary, how do we check it? What do we do with the 4?
You would put the 4 in for x, so 4 plus 6 equals 10.
Yep. So we're going to just check it off to the side. 4 plus 6 equals 10. Now, we haven't checked it yet. We're not done. We have to actually do this out. And how about, Jake, what's 4 plus 6 give me?
4 plus 6.
10. Good. So we get 10 equals 10. Does 10 equal 10? Mm-hmm. Yes. Yeah. So when you check it, that should always be your last step. 10 or a number, and then it's the same number on the other side. What if you checked it and you got like 3 equals 4? What happens if you check something and that happens? What could that mean? It could mean two things. Yeah?
It's not equal to each other.
Right. It's not equal to each other. So, Mary, what does that mean?
You probably messed something up in solving the problem. You probably just added wrong or subtracted wrong.
Yep. So we might have messed something up when we solved the original problem. Where else could we have messed something up besides when we solved the original problem? Yep.
In the check step.
In the checking part, we could We could have done 4 minus 6 and said, oh, negative 2, okay? Or we could have made a mistake like that. So if you don't get the same number on both sides, something's wrong. All right, so last thing we're going to look at is a word problem. So remember, with word problems, there's certain phrases, okay, that are important.
And we talked about last week.
Yep, and we talked about them last week. So we got to make sure we understand what the phrase is, and then how do we change it to like a math symbol, like is means equals, as Roy said. All right, so let's just look at a couple phrases.
Yeah, some of you guys may have an example, like you might have wrote like that example, for example, free on your notes. That's okay. If you have an example, free blank, that's okay too, you're not wrong.
All right, so as far as putting this on your notes, I think we already wrote these last week.
Yeah, don't worry about
So-
that. We just kind of blacked out, guys, what it means. That way we'll ask you guys and we'll uncover it.
For more than a number. How would you write that without the words more than? So I want to see a for and number. Well, pick a variable. So you're going to have a number, you're going to have a variable, and then an operation. Like add, subtract, multiply, divide. Yeah, times.
Is like greater than 4.
So we're going to be careful. If it said 4
Oh.
is more than,
Then it's the other way.
yeah, then it would be an inequality.
Alright.
But where it says just more than, that's either add, subtract, multiply, or divide. So I know it's a small word, but it's kind of important. If it says more than or is more than. If the word is was in there, you would be right. Yep.
You would add 4 to whatever number.
Yeah, you would add. So can you tell me, pick a variable for the number?
4 plus x.
Sure, 4 plus x. Or x plus 4. Okay, with addition, the order doesn't matter. Okay, doesn't matter. How about 16 less than a number? 16 less than a number. Yep, Ellie?
X minus 16.
Exactly. See, it's a tricky one. I thought it might trip some people up. But 16 less than a number. So if I said to you, all right, in your head, think of a number. Say you thought of the number 20. And then I said, okay, 16 less than 20. Well, if you want to figure out what's 16 less than 20, you do 20 minus 16. The number that's at the end comes first. The number that's at the beginning goes last. So 16, or x minus 16, exactly what Ellie said. Or n minus 16. Same
Yeah,
thing.
so we talked about last week when it's less than, you kind of want to take the opposite of what you think, like flip the order.
A number decreased by 16. Let's just start with the operation. Well, we're just dealing with adding and subtracting today. So, decreased by. Add or subtract? Savannah? Subtract, yep. Now, let's use n as our variable since we've been using that all along. How would I write a number decreased by 16? Yeah.
16.
So let's say you had a number in your head. Pick a. Well, let's do the number we did before. Let's do 20. If I said to you 20 decreased by 16, how would you write that? Right, you'd write it in exactly the order you see it. So now, we're not using 20, we're using just number. So how would you write that? Exactly, n minus 16. Okay, that's how I do it. If I get tripped up with a word, I say, all right, let's pretend that it was an actual number. What would I do? And then I do the same thing here. It's not 20 minus 16, it's n minus 16. Okay, so any questions on that? More than, less than, decreased by. What's one other way you can do addition? Anyone remember another, it's actually just a single word? Yep, Chris? Yep.
Increase.
Yeah, increase by. I wasn't thinking of that one, but yep, increase by. And there's one other word. Sum, exactly. That's the one I was thinking of. What word goes with sum for subtraction? Yeah.
Difference.
Difference. Nice job. All right? So I didn't put all of them up here, but just a couple. All right, so example 5. So yeah, it's already written for you. It says the price of a shirt was X dollars. The price increased by 7 and is now 32. Write and solve an equation to find the original price. Could you do this without an equation and probably figure it out? Yep. Eventually, though, we might get into problems that you can't just kind of guess the number in your head, because maybe it's a decimal and you'd never guess that kind of answer. So we want to make sure you guys can set up an equation. All right, price of a shirt was X dollars. They're telling you the variable. So we know we're going to use X. And it increased by 7 and is now 32. Let's look at the word increased. Okay, what operation is increased in math? Ellie?
Addition.
Addition. I'm just going to put a little addition sign above that. So this problem is going to have addition in it somewhere. How about in that second sentence? The price increased by 7 and is now 32. Any other word there that's important? I mean, I know increased is important. I know the 7 and the 32 are important. Numbers are always important. But there's another word there that's important. Yeah, Nicole?
Is.
Is. Yeah, what does is mean? So what math symbol could we change is to? Mary?
Equals.
Equals. All right. So I think now we've got some symbols. Let's start to write it out. So increased by, that's addition. Well, something's increasing by $7. What is increasing by $7? Yep, Ryan?
5.
What's increasing by X dollars?
That's gonna be your answer, buddy, yes.
Yeah.
You're like ahead of me.
7. Never mind. Here's something else.
Yep, Melanie?
The price of the shirt.
The price of the shirt is increasing by $7. What's the price of the shirt? Ellie?
X.
So
X.
we don't know yet.
The price of the shirt is increasing by $7. Whoops, I kind of jumped ahead a little bit. So that's increasing by $7 and is 32. Is, there's your equal sign, 32. Now we've kind of taken out all the words from the word problem. Now we just have an equation. Okay, that's probably the hardest part in a word problem. Trying to take what they give you and turn it into an equation. So Alex, what do I have to do now to both sides?
Subtract 7.
Yep. Subtract 7. Subtract 7. And David, 7 minus 7 gives me...
Just cancels out.
Cancels out. That's gone. Then the jelly, what's on the left-hand side now?
Oh,
X is on the left. Equals. And page 32 minus 7 is going to give me 25.
Are we done?
No.
What else do I need
Can you
here?
scroll up? On a test or something, you'd be done. What doesn't it say? Ellen?
To check it.
It doesn't say check, right? You could if you wanted to, but if it doesn't say you have to, you don't have to. You'd be done in this case.
Anything else on that answer that we want to put? Because remember, this wasn't the original problem. We didn't just give you an equation and say solve. We gave you all of that. So what do you think you have to do with that? Chris?
At 25, leave the X in place.
No, like Mr. Roy said, the answer's good. I mean,
You solved it correctly.
we've solved it correctly, but might lose a point for something like that.
Look at the last sentence of the problem.
Yeah, Gigi?
Did you put the dollar sign?
put a dollar sign in there.
Deal with money.
So if you're dealing with money, put the dollar sign. If you're dealing with distance, maybe we put feet. I think length we deal with at some point,
Yeah.
distance, and money we deal with a couple times this year. But just make sure you label your answer in a word problem. All right, any questions on that? All right, so I think we got a couple reminders, Mr. Roy?
Yeah.
Perfect. Okay, so tonight, homework, it's gonna be just like it was last week. You're gonna get a worksheet. The worksheet will be up on,
You guys,
You
leave
too?
those notes up, and there's a couple practice problems I want you guys to do before we leave you alone.
if there's anything else you need to have signed, whether it's the blue sheet from your agenda, the white sheet that goes to the dean's office, or our syllabus, but I think everybody gave you that. Make sure you bring that in. Okay, try to get a binder. Okay, so hopefully we'll have some time this week. I know we have the assembly on Wednesday, so we'll see what happens. But we definitely, next week, we have a review day on Thursday. So that day we're gonna try to use to catch up on a few things. If we need to finish setting up a binder, we'll do it. We're gonna try a MCAS problem. So throughout the year, like usually once a term, we'll just practice an MCAS question. So when you guys take MCAS next year, you'll kind of know what some of the 10th grade problems are like. I know you all took it in 8th grade, but 10th grade one's a little different, so we're gonna try some of those. Not this week though, next week. And then our first test for the term is this Friday, okay, the 14th.
Guys, another thing that we need to put on there, make sure you get yourself signed up for Google Classroom, all right? Because the reference sheet for this week, the one where you have to go back and actually write in examples from the notes we've taken, probably gonna put that up there I'm gonna try to do it like Wednesday. That way you guys can get a jump start on it, so you're not doing it all Thursday night along with the test review.
If you need the code again, I can email it to you.
What if you did like the one for history and history class for Google Classroom? You just add on the classes.
You're gonna sign up for our class.
Okay.
Yeah, every Google Classroom has its own code. I know I gave you guys the code the first day. I think I have one extra somewhere, but I can email you all the code, so that way you can just copy and paste it. Okay? Would that be helpful if I just email it out? You have it? Okay. Perfect.